Students of class 10, chapter is triangles, exercise 6.4. The first question is, let triangle ABC similar triangle DF and their areas be respectively 64 cm 121 centimeter square. If EF is equal to this much, find BC. So question number 1, here ABC and DEF. Here triangle ABC, this is given, triangle ABC similar triangle DEF, and area triangle ABC is equal to 64 centimeter square, and area triangle DEF is equal to 121 centimeter square, and EF is equal to 15.4 centimeter. We have to find out to find BC. So here solution, since your triangle ABC is similar triangle DEF, therefore area triangle ABC by area triangle DEF, this will be equal to AB square by DE square is equal to BC square by EF square is equal to AC square by DF square. This I get from theorem 6.6. This I get from theorem 6.6. Now here you see uh, uh, here this area triangle ABC by area triangle DEF, this is equal to BC square by EF square. Now area triangle, this is 64 by 121 BC square by 15.4 the whole square. So this comes out to be 64 means 8 square by 11 square is equal to BC square by 15.4 the whole square. So 8 by 11 is equal to BC by 15.4. So 8 by 11 into 15.4 is equal to BC. This comes out to be 11 ones are 11 and 11 ones are 11 and 4.4. So this will be 1.4. So 8 into 1.4 is equal to BC. So 4 8 are 32, 2 3, 8 1 is 8 plus 3, this will be 11. 11.2 centimeter is equal to BC. This is your answer. 16.4, this is 6.4, 6.4, 11.2, this is your 11.2, this is your answer. Now question number 2. Question number 2, that is, diagonals of a trapezium ABCD with AB parallel DC intersect each other at O. AB is equal to twice CD. Find the ratio of the area of triangle AOB and COD. Now question number 2, here this is your trapezium, and this is your trapezium, and A, B, CD. AB is parallel to DC and the diagonals intersect at O. These diagonals intersect at O, and here it is given that ABCD is a trapezium. This is a trapezium, and AB is parallel to DC. This is given to you, and diagonals intersect at O. Diagonals intersect at O. Now AB is equal to twice CD. We have to find that is ratio of area triangle AOB by area triangle COD. Now solution, that is in triangle AOB and COD, triangle COD, since your AB is parallel to DC, therefore angle OAB is equal to angle OCD, and angle OBA is equal to angle ODC. They are alternate angles, and angle AOB is equal to angle DOC. They are vertically opposite angles. So triangle AOB is similar to triangle COD from AAA. When these two triangles are similar, then area triangle AOB by area triangle COD, this will be equal to OA square by CO square. This will be equal to OB square by OD square. This will be equal to AB square by DC square. So DC, you can write CD square. So area triangle AOB by area triangle COD, this will be equal to AB square by CD square. Now it is again area triangle AOB by area triangle COD. Your AB, it is given twice CD, so 2CD the whole square by CD square. So area triangle AOB by area triangle COD is equal to 4CD square by CD square. So this comes out by 4 by 1. So ratio is 4:1. This is your answer. Now 6.4, your 6.4, question number 2. This is 4:1 ratio. Now question number 3, that is question number 3. Here question number 3. Here you see the figure, it is given to you, and we have to show that area ABC is equal to DBC. So the figure, it is given to you. This is the figure A, B, D, C. and O. Uh, mm, mm, Given, this is given that triangle uh, mm, triangle ABC and triangle DBC are two triangles. They are two triangles on the same base, BC, and AD intersect BC at O to prove that area ABC by area DBC is equal to AO by DO. So we have to do a construction that is AM perpendicular to BC and DN perpendicular to BC are drawn. AM perpendicular to BC and DN perpendicular to BC are drawn. Now proof: in triangle AMO and triangle DNO, angle AMO is equal to angle DNO. This is 90 degree, equal to 90 degree. This I have got from construction. So again, angle AOM is equal to angle DON, that is vertically opposite angles. So your triangle AMO is similar triangle DNO from AAA similarity theorem, Now these two triangles are similar. So here what you get that AM by DN is equal to MO by NO is equal to AO by DO. This is the conclusion I got from this two similar triangles. Now again, here you see that now area triangle ABC by area triangle DBC, this is half base BC into height AM, half base BC into height DN. So this comes out to be AM by DN. Now from equation 1, this is equation 1, we get that AM by DN is equal to AO by DO. So therefore area triangle ABC by area triangle DBC is equal to AO by DO. This is proved. Now question number 4. If areas of two similar triangles are equal, prove that they are congruent. that is two triangles. It is given to you A, B, C, and another triangle that is D, E, F. Now it is given that area triangle ABC is equal to area triangle DEF. This is given to you. So area of two similar triangles. At the same time, it is also given that area at the same time it is also given that triangle ABC similar triangle DEF. These two things are given to you. You have to prove that triangle ABC is congruent to triangle DEF. So proof. Since your triangle ABC is similar to triangle DEF, so from theorem, this is theorem 6.6, that is area triangle ABC by area triangle DEF, this will be equal to AB square by DE square is equal to BC square by EF square is equal to AC square by DF square from theorem 6.6. Now here again, since area triangle ABC is equal to area triangle DEF, so here this is equation 1. So from equation 1 we get this is equal to 1. So AB square by DE square is equal to BC square by EF square is equal to AC square by DF square. So from here we get that 1 is equal to AB square by DE square. So DE square is equal to AB square. So DE is equal to AB. Similarly, we get that EF is equal to BC and DF is equal to AC. Therefore, triangle ABC is congruent to triangle DEF from SSS congruency. So this is proved. Now question number 5. D, E, F are respectively the midpoints of side AB, BC, CA of triangle ABC. Find the ratio of the area of triangle DEF and ABC. So here this question number 5 in this way. It is better that you solve this question in this way. This will be very easy for you, and this will be according to the theorem given in 6.6 D, E and F. So here you better do this in this way. So since I was uploading it, so I didn't want to cancel it. It will be better if you do it in this way. It is given that in triangle ABC, D, E and F are the midpoints of AB, BC and AC. To find a ratio of area triangle DEF by area triangle ABC. This you do the solve this problem question of 5 in this way. The earlier which I proved you, this is also correct, that is also correct, but since I was uploading the video, so I did not want to cancel it, but it would be better if you do this problem in this way. It would be better if you do it in this way. So here you see solution. This is the solution. Solution is that since D and F are the midpoints of midpoints of they are the midpoints of AB and AC. Therefore, DF is parallel to BC and DF is equal to half of BC. This is from midpoint theorem. That is joining the a line joining the midpoints line joining the midpoints of any two sides of a triangle. Any two sides of a triangle is parallel parallel to the third side and is half of it and is half of it. So here therefore DF is parallel to BE and DF is equal to BE, since E is the midpoint of is the midpoint of BC. So here what do you get here? That is therefore BE FD is a parallelogram is a parallelogram Therefore angle B is equal to angle DFE, because opposite angles of a opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. Similarly, DF CE is a parallelogram is a parallelogram is a parallelogram. Therefore angle C is equal to angle EDF. Again your ADEF is a parallelogram therefore angle A is equal to angle DEF. So now triangle triangle DEF is similar to triangle DC EA and FB. Similar to triangle, since D angle is equal to C and your B angle is equal to F and your A angle is equal to your E. So DEF. So so it will be DEF. So CAB. This is from AAA similarity from AA similarity. This is similar. Now here area triangle DEF by area triangle DA AB DE and F. Okay, triangle CAB that will be equal to DE your that will be equal to E, opposite side is that will be equal to DF square by df square df square by bc square is equal to bc square is equal to your ef square by ab square, and this will be equal to uh, de square by ac square from theorem 6.6. Now area uh, uh, df area triangle DEF is by area triangle CAB. DF it is half of BC. DF it is half of BC. So half BC the whole square by BC square. So area triangle DEF by area triangle CAB is equal to 1 by 4 BC square by BC square, and this will be area triangle DEF by area triangle CAB is equal to 1 by 4. Because here in the question it is ABC. In the question the ratio was ratio DEF and ABC, but in the figure you see your angle D is equal to angle C, and angle A is equal to angle E, this, and angle B is equal to angle DF E. So I have to, instead of ABC I have to write C, because D is equal to C. So first E is equal to A and F is equal to B. So I have to write it like this, CAB. So 1 is to 4, 1 by 4. The ratio is 1 is to 4. This is your answer. Question number 6. Here, prove that the ratio of the areas of two similar triangles is equal to square of the ratio of their corresponding medians. That means this is two triangles A, B, C, and another triangle D, E, F. Now, it is given that given ratio of the areas of two similar triangles. Uh, Two similar triangles means triangle A, triangle ABC is similar triangle DEF. Area of two similar triangles. It is given that the area these two triangles are similar. Now to prove that equal to the ratio of the cos, prove that area triangle ABC by area triangle DEF is equal to AM square by DM square. This I have shown only one for you. The for rest of the medians it will be the same procedure. So at last I can conclude that we can conclude that it is um, uh, that means actually I have to prove that let square of their medians. That means I have to prove that this like this. This is mm, let me name like this, then it will be far better. M, N, and this be O, and here P, this will be, let this be P Q and this B R. So actually I have to prove like this very statement: am square by dp square is equal to bn square by eq square is equal to co square by fr square. I have to prove like this. Actually, I have to prove like this. But what I am going to do, I am going to prove only one, and similarly I will write for the others. Actually, I have to prove like this. They were 1 minute. Let me make this. It will be better if I write like this. Given that is triangle ABC is similar to triangle DEF, and AMBN and CO are the medians of triangle ABC, and DP, EQ and FR are the medians of triangle DEF. To prove that area triangle ABC by area triangle DEF is equal to AM square by DP square is equal to BN square by EQ square is equal to CO square by FR square. This actually I have to prove this very statement, but I am going to prove only one part of it, and similarly I will write for the others. So proof here, um, proof here, since triangle ABC is similar to triangle DEF, this is given to you. So from theorem 6.6, area triangle ABC by area triangle DEF, this will be equal to AB square by DE square is equal to BC square by uh, uh, oh yeah, not this. Since they are similar, therefore, AB by DE is equal to BC by EF is equal to AC by DF. Now here I am going to take AB by DE is equal to BC by EF. Again, yes, you see AB by DE is equal, instead of BC I am going to write twice BM by twice EP. Why? Since AM and DP are the medians of triangle ABC and triangle DEF. These are the medians. So AB by DE is equal to BM by EF. Again, angle B is equal to angle E. Why? Since triangle ABC is similar triangle triangle DEF. This is given to you. Therefore, your triangle ABM is similar triangle DEP. Now, here you see, therefore, your sides are proportional. AB by DE is equal to AM by DP is equal to BM by EP. Since They are similar, therefore the sides are, this is from SAS similarity. So the sides are proportional. Now we know that since your triangle ABC is similar triangle DEF, this is given to you. So your area triangle ABC by area triangle DEF, this will be equal to AB square by DE square. DE square is equal to BC square by EF square is equal to AC square by DF square from theorem 6.6. Now I am going to take area triangle ABC by area triangle DEF is equal to AB square by DE square. So here from equation 1 you see AB by DE is equal to AM by DP. So from, and therefore area triangle, here you see this, here triangle ABC by area triangle DEF, I can write, instead of AB by DE, I can write AM square by DP square. So now similarly I can I can say that area triangle ABC by area triangle DEF is equal to AM square by DP square is equal to BN square by EQ square is equal to CO square by FR square. This is proved. 1 minute, I have done a little, this is okay. Bn square by Eq square is equal to CO square by FR square. So this is proved. Now the last question is, prove that area of an equilateral triangle described on one side of a square is equal to half the area of the equilateral triangle described on one of its diagonals. That is, this is a square given to you. This is a square given to you, and an equilateral triangle is inscribed on one side of a square, this, and another equilateral triangle, it is described on the diagonal. So let me name A, B, C, D, E, F. So it is given that A, B, C, D is a square, and triangle AEB and triangle DFB are two equilateral triangles. They are two equilateral triangles. Now we have to prove that area triangle AEB is equal to half area triangle DBF. So proof. Let AB equal to A unit. So since your ABCD is a square, therefore DB square is equal to DA square plus AB square from Pythagoras theorem. Now dB square, since all sides of a square are equal, therefore this is equal to A square plus A square your dB square is equal to 2a square. So dB will be equal to root 2a. So your dB will becomes to root 2a. This is also a, and this will be root 2a, root 2a. Now, since your triangle AEB is similar triangle DBF, because they are equilateral triangle, equilateral triangles, therefore they are similar from AAA, similarity, because they are similar. Therefore area triangle AEB by area triangle DBF is equal to AB square by AB square by BD square, from theorem 6.6. So for area triangle AEB by area triangle DBF, your AB is a square, BD is equal to root 2a the whole square, a square by 2a square, that is equal to 1 by 2. Therefore area triangle AEB is equal to half area triangle DBF.